All right, good afternoon. Sorry I'm not in today, but Elijah has influenza A, we found out this weekend. So, um, yeah, I'll be home today. Hopefully, I'll be in tomorrow. But that's okay, because today we're going to be dealing with geometric sequences. Before I forget, remember that your 12.2C worksheet, that yellow worksheet, that's due today. If you didn't get one, there's one available for you to print out on It's Learning, and that's due today, even if you were gone Friday, because you all got it on Thursday. So if you were gone Thursday and Friday, then we can figure it out tomorrow when I get back, but that one's due today. So in 12.2, we were talking about arithmetic sequences, and we talked about A's, and we were adding, and it was all that fun stuff. Today we're in geometric sequences, and tomorrow we'll be in geometric series, and then Thursday we'll be in applications of geometric sequences and series, and Wednesday I'm thinking we'll have another online formative assessment just as an FYI, and hopefully it'll run a little smoother this time than it did last time. So let's dive into this. A geometric sequence is a sequence that has a constant ratio. Okay? Last time it was a constant difference. This time now we're talking about a constant ratio between consecutive terms. Okay? So the basic idea here is that we are now, instead of adding to get the next term, we are multiplying. Okay, so we're going to multiply to get the next term. Okay? So that means that if I am looking for R, my constant difference R, I don't know why that was in blue, it should have been in red. Why that's in blue, I don't know. I say. If I'm looking for my R term, okay, I'm going to take any term and divide it by the term right before it. Okay? So we added in the last week to get those sequences in series, so now we're going to multiply. So if I take any term, I divide it by the term right before it, that tells me what R is. If my sequence is growing, my R is going to be bigger than 1. If my sequence is getting smaller as we go along, each term is getting smaller, my R is going to be less than 1. R can be positive, R can be negative. Okay? Many different options there for R. Okay? So if I'm looking at these sequences, now what I'm looking for is I'm looking for what I'm doing to get to the next one. So if I'm first looking at it, I would say, okay, well, if I'm thinking arithmetic, it's plus 2. But then it goes plus 4. So I know that that one is not arithmetic. However, I can multiply by 2, and multiply by 2, and multiply by 2, and multiply by 2, and that right down here, those are all the same. I'm always multiplying by 2, so my R value here is 2, and it's a geometric sequence because it's got commas in between. So because it's geometric, then it's not arithmetic. Okay? Next one here is an example of one that's getting smaller now. So if I'm looking at it, okay, well, I'm multiplying by 1/2, multiplying by 1/2, multiplying by 1/2. If I don't see that I'm multiplying by 1/2, I can take any term in that sequence, for instance, 50, okay? So if I lock it in at 50 here, then I would divide 50 by the term right before it. So I would divide 50 by 100. Okay, and then that would be, I'd reduce that. 50 goes into 100 twice, so that's 1/2. So my R value here is 1/2. Okay. Again, here with negative numbers, okay, I'm multiplying by -2, multiplying by -2, multiplying by -2. So my R value there is -2. Okay. Determine if the sequence is geometric. Find the common ratio if it is geometric. Okay. Well, looking at this first one, 15, 25, 35, 45, it appears that I'm adding 10 there, I'm adding 10 there, I'm adding 10 there. So that means that that's not geometric. That means that this one is actually arithmetic. So this answer here is no, it is not, because you can't be geometric and arithmetic at the same time. And for some reason, the smartboard that I'm using won't select. See, it won't. I don't know why it won't let me do it. Oh well. So no funky boxes today. Okay. Another thing you could have done here is you could have said, well, 25 divided by 15 is going to be 5/3. 35 divided by 25 is going to be 7/5 if I divided all those by 5 to reduce that fraction. These two not the same, so therefore not geometric. Okay? In this next one, multiplying by 4, multiplying by 4, multiplying by 4. So yes, this is geometric. And my R value is 4. In C here, okay, kind of hard to figure out what it is, kind of hard to see what it is, so let's go with -9 divided by 27 and see if that equals 3 divided by -9 and see if that equals -1/3, because that would be -1 divided by 3 would be -1/3. Well, this fraction here both can be divided by 3, so that becomes 1 over -3, which is equal to -1/3. In this fraction here, both can be divided by 9, -1 over +3, both equal -1/3. So yes, this one is geometric. With R equaling -1/3. Okay. Here, adding 2, adding 2, adding 2. So that's going to be arithmetic. Checking of the geometric. Here I'm multiplying by 2. Here I'm multiplying by 1.5. So right there, that's not geometric. So this one is actually, oops, forgot. Can't just hit the button. Push it down there. So no there. Okay. The rule that we have for arithmetic, or excuse me, for geometric sequences and series, to find any term, so G sub n. Notice how we've switched now from A sub n to G sub n because we're talking about geometric series here now. Okay, so any term is equal to the first term of the sequence times the common ratio r to the n minus 1 power. Now, I again think that that is note card worthy, since you have a quiz this week Friday. Okay? So on your note card you could do one side arithmetic, you could do the other side geometric, and then you would have a nice little organization going on for that. Give you a couple of seconds to write that down. Write the rule for the geometric sequence, then find G sub 7. Okay? Well, here's what my rule is. G sub n, any term is equal to the first term times r to the n minus 1 power. Okay? So what I need from that to write the rule is I need my first term, I need my r value. If I'm writing the straight up rule, that's the two things that I need. In this case, my first term is 4, and my r value is going to be 2, because I take any term. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. Or, what times 4 gets me 8? That's 2. What times 8 gets me 16? That's 2. So there's that. So my rule then would be G sub n for any term is going to equal 4 times, and I like to put the r in parentheses, 2 to the n minus 1 power. Now, what we're going to do is now we're going to find G sub 7. So my n now is going to be 7. 4 times 2 to the 7 minus 1 power. 7 minus 1 is 6. So this is 4 times 2 to the 6th power. 2 to the 6th power is 64. So this is 4 times 64. 4 times 64 is 256. So G to the 7th is 256. So my rule, I don't know why, so my rule is here, and my G sub 7 is there. Okay. On part B, okay, so we need G sub 1. That's going to be my first term, 2/3, right there. Okay. I need my r. Well, my r is going to be any term, 1/2, divided by the term right before it, which is 2/3. Okay. Remember, when we're dividing fractions, we flip the second one and we multiply. So my r value here is actually 3/4. If that's the case, then my rule, G sub n, is 2/3 times 3/4 to the n minus 1 power. That's the rule. Now to find G sub 7, that's going to be 2/3 times 3/4 to the 7 minus 1 power. So that's going to be 2/3 times 3/4 to the 6th power, which is 2 over 3 times 3 to the 6th over 4 to the 6th. And if you do that math, if you figure out what that fraction is, after you simplify it, you get g sub 7 is 243 divided by 2048. Another style of problem, write a rule given one term and the common ratio. So we know what the 6th term here is negative 16. We know that r is 2. Okay? So if I know that, I'm going to start with my rule. G sub n is going to equal G sub 1 times r to the n minus 1 power. If I know the fact that negative 16 is the 6th term, then negative 16 is going to be that term. My first term I don't know. My r value I know is 2. I know that this is the 6th term, and that would then be subtracted with 1. 6 minus 1 is 5, so this is negative 16 is my first term times 2 to the 5th power. 2 to the 5th power is 32. If I divide both sides there by 32, I get negative 1/2 is my first term. So that's going to give me enough information then to write my rule. G sub n then is equal to my first term, negative 1/2, times my r value of 2 to the n minus 1 power. Again, starting with G sub n is the first term times r to the n minus 1 power. So that means then that 12 is my first term times negative 3 to the 4 minus 1 power. 4 minus 1 is 3. Negative 3 to the 3rd power is negative 27. 12 divided by negative 27 is going to be, so 12 over negative 27, because you divide both sides by that, is going to be, both can be divided by 4, so we get negative 4/9 there in reduced form. So my rule is negative 4/9 times negative 3 to the n minus 1 power. Okay. Last one, I'm going to show you one of these, okay, and how to do those. And then, so we're actually going to do F there, and then I want to show you a special case one, and then we'll be done for the day. So, I have my rule, G sub n. So, in the first one, I'm going to say that negative 3 is equal to my first term times r to the 2 minus 1 power or that negative 3 is just g sub 1 times r. Now, what I'm going to do with one of these, and the second one I should just do right away, 81, that's a wake-up call for you, is g sub 1 times r to the 5 minus 1 power, or 81 equals g sub 1 times r to the 4th power. Now, what I'm going to do with one of those equations, in this particular case I'm going to go with the left one, I'm going to solve that for g sub 1. So that's going to be negative 3 divided by r equals g sub 1. Then what I'm going to do with that is I'm going to take that and I'm going to substitute it in to the other equation. So we get 81 equals, now it's negative 3 divided by r times r to the 4th. So this becomes 81 equals negative 3 r cubed. When you simplify it, r to the 4th divided by r is r cubed times negative 3. Divide both sides by negative 3, we get negative 27 equals r cubed. Take the cube root on both sides, and we get negative 3 is r. Then I'm going to take that and I'm going to substitute that back into there, and I'm going to say, well, negative 3 divided by negative 3 is my first term, so in this case, 1 is my first term. Now I have everything that I need to write my rule, and my rule then would be g sub n is equal to 1 times negative 3 to the n minus 1 power. If you don't write the 1 there in that case, because your first term is equal to 1, I'm okay with that. So it could look like that, and I would be okay with that. Those mean the exact same thing. Okay? So that's how you do those problems. You set up two rules, solve one of your rules for one of your variables, plug it into the other one, solve it, make it look nice and pretty. Okay? And helpful hint, you're always going to go with the one that's got the smallest exponent on r. That's the one that you're going to want to solve for the first term and substitute that in. Easiest to do it that way. Okay? Special case of this one, same style of problem as that one. So let's set it up. 48 equals my first term times r to the 4 minus 1 power. So 48 equals my first term times r cubed. 3072 equals my first term times r to the 10 minus 1 power. So 3072 equals my first term times r to the 9th power. Again, my left one has a smaller exponent on r, so 48 divided by r cubed there is my first term, and then that is what I'm going to substitute in there. So then that becomes 3072 is equal to 48 divided by r cubed times r to the 9th. R to the 9th divided by r cubed is r to the 6th. So this is 3072 equals 48 r to the 6th power. dividing both sides by 48 gives me, I want to say 64. Then taking the 6th root on both sides gives me 2 equals r. Put it in the wrong color. 2 equals r. Then what we're going to do with that then is I'm going to substitute that back in over here. So I get 48 divided by 2 cubed is my first term. 2 cubed is 8. So 48 divided by 8 is my first term. So 6 is my first term. Okay. But the kicker is that way back here, because we took an even root on this one, that means that this needs to have a plus or minus in it. So I have to do that again. So I'm going to have to substitute twice into that equation. So then the other one is 48 divided by negative 2 cubed. Well, that's going to be 48 divided by negative 8. So that's going to give me negative 6 is my first term. When we take the root, and it's an even root, we have to go with plus or minus there for it. Okay? So I've got 2 rules here now. This rule is for when r is equal to negative 2. I'm going to use that and that. This one is for when r is equal to positive 2, and I'm going to use both of those. So my red rule would be g sub n equals 6 times 2 to the n minus 1 power. My other one is going to be g sub n is going to equal negative 6 times negative 2 to the n minus 1 power. And both of those are my answer, because both of them give me 48 for the 4th term and 3072 for the 10th term. Okay? All because right here we took an even root. If you're taking an even root to find r, this double aspect, this 2 rule aspect comes into play. Okay? Don't worry, I'll explain more about that on Tuesday when I return. So here is your homework. It is the 12.3a homework. It will be due on Tuesday, and I'll make sure we have time on Tuesday to answer questions if we have any questions at the beginning of class. Okay, hope you have a great day. Hope you had a great weekend.